Welcome to the Parabolas notes. At the end of this video, I will show you an example of why parabolas are actually important. But to get us started, in case you're just here to learn how to graph one, I'm going to go ahead and explain the most important parts. First things first, the vertex is basically the turning point of the curve right here in the middle. Then there is a focus point right here. And that focus point actually has a lot of really important real-world applications. But the main idea behind a parabola is that every point on this curve is the same distance from this gray vertex or gray focus point as it is from this dashed line right here. And we're going to go ahead and call that distance P. So notice how, for example, the vertex is exactly P units away from the directrix and P units away from the focus. That's the whole idea. Now, one example I have is this point all the way over here. That point is technically P and P, or 2P units away, so it must also be 2P units away from the focus as well. So we are going to use that distance to find points on the curve. They don't really have a special name. We just can't draw a curve if we only have the vertex. So those 2 points allow us to actually draw the rest of the parabola. Now, the axis of symmetry goes through the vertex and the focus like this. And it just means that if you flipped this half of the graph, you would get exactly this half of the graph. It's just trying to show that parabolas are indeed symmetrical. We are not going to actually draw it on ours. We're just going to focus on the vertex, the focus, and the dashed line called the directrix that is right here. In fact, let's go ahead and label it so that we know what it is. Directrix. There you go. Okay, so there are 2 types of parabolas. And in order to learn the 2 types, we're actually going to take a look at the equations. You will notice that as in every equation of every other conic section, you have x minus h and y minus k. Now, the one thing that is the most unique about a parabola is there's no squared. And if x is the variable that's not squared, it's going to be a horizontal parabola. If the value in front right here is positive, then it's going to go to the right like this. If that value in front is negative, it's going to open up to the left like this. And if the missing squared part is on the y instead of the x, it's going to be a vertical one that opens up if p is positive and opens down if p is negative. And that's basically how the 2 equations work. The very first one has no squared on the x part. Because of that, it is going to be a horizontal one. And because of that, I'm going to go ahead and plot my vertex, which is going to be at 1, 6. Remember that just like a circle or an ellipse, we are always going to change the signs of both of those numbers because they are being subtracted in the formula. So I'm going to go ahead and put the point over 1 up 1, 2, 3, 4, 5, 6 on my graph. That is the vertex. In fact, some people like to go ahead and label it as V. You're welcome to if you would like to. Then I have to go plot the focus. And just like I showed you up here, the distance from the vertex to the focus is P. P is being multiplied by 4 on the bottom of that fraction. So in this case, 4p equals 12. And if 4p equals 12, then p equals 3. So the focus needs to be 3 units away from the x spot of the vertex, since x is the non-squared variable. So it's going to be right here. Again, this is what tells me that the focus is to the right. Then I do kind of the same thing, but I go 3 units in the opposite direction and draw my dashed line for the vertex. So the directrix is always going to be negative p units away from the vertex. And it is always going to be perpendicular to the axis of symmetry, which technically goes side to side. Then I'm going to go ahead and draw the 2 points on the curve. Since the distance from the directrix, and I'm going to go ahead and do this in highlighter, the directrix to the focus is 6 units. That means that from the focus, F, if you want to label it, I go up and down 6 units to draw my 2 other points on the curve. So 1, 2, 3, 4, 5, 6. I know that goes off of the graph a little bit. And 1, 2, 3, 4, 5, 6. And then I just draw my curve like this. And that's my parabola. Now that point F that I labeled is the point 4, 6, because it's to the right 4 and up 6. And the directrix is located where x equals -2. So it is simply x equals -2. And I'm just going to throw a reminder out there of Hoyvux, which tells us that horizontal lines are y equals and vertical lines are x equals. Since this directrix is going up and down, that's why it's an x equals equation. Let's try another one. The more we do, the easier it will get. The next one is going to be a vertical parabola because it is x squared instead of y squared. Y is the one that is not squared. Just be careful with the vertex. Most people will say that it's -3, 2. It's actually 2, -3, because you always need to make sure that you're putting x before y. The order of the equation on this one does look a little misleading. So that is going to be the point that goes right 2, down 3, right here. Then, if the bottom of the fraction is 4p, then 4p equals 8. And if 4p equals 8, then p equals 2. And when we move 2 units to find the focus, I have to do that in the vertical direction. So up 2. And that is my focus, which is the point 2, -1. Then my directrix is 2 units in the opposite direction, which is down 2. And because of the direction that the vertex and the focus are going, the directrix is going to go this way. If it helps you decide which way to draw this line, the directrix should not go through the focus. And if I drew this line going up and down, it would go right through the focus. It's supposed to sort of be like a repellent line on the other side almost. In that equation, because it's horizontal, is going to be y equals, and that line is located down 5 units, so it's going to be y equals -5. Then, since the distance between the directrix and the focus is 4 units, I'm going to move 4 units to the right and to the left to give myself extra points for the curve. One more, and then we'll talk about the equations. So the next one is also going to be vertical because y is not squared. The vertex is going to be 6, 4. Because again, I'm putting x then y. And it's coming from these two numbers right there and right there. Always the opposite because they're being subtracted inside of the formula. Then for p, it's actually going to be negative because 4p is going to equal -2. Which, if I divide by 4, p equals -2/4, or -1/2. So I'm going to go ahead and put my vertex over 6, up 4, vertex. Oops. And then I'm going to make my focus go -1/2 in the vertical direction, which is going to be right there, just down 1/2. Now, this one is so small, I'm going to go ahead and zoom in on it so that everybody can see it. Since I only went down 1/2, that means that that point is still over 6, but instead of being up 4, now it's only up 3.5, because I went down 1/2 unit. And my directrix is going to be 1/2 units away on the other side, so it's going to be right here at y equals 4.5, because the vertex was at 4 and I went up 1/2. Now, it's a little hard to see, but the distance between the focus and the directrix is actually 1, because I did 1/2 twice. So that means that I'm going to move over from the focus 1 whole unit. And since I put the V there, I'm going to go ahead and move it like right here. Over 1 on each side, like that. And there is my parabola. It's kind of a skinny one because P was so small. And notice how it naturally ended up going upside down because P was negative. Now let's talk about how to write the equation. For the first example, it says write the parabola with a vertex at 0, 0 and a directrix at x equals -6. I'm going to draw a little bit of a sketch over here on the left. So if the vertex is at 0, 0 and the directrix is at x equals -6, that's going to be over here on the left somewhere. So the parabola is going to have to go this way, away from the directrix. So it's a horizontal one where P is going to be positive because it's facing towards the right. But since this is horizontal, it's going to be x minus h, which is 0, equals 1/4 times P, which is 6 units because the directrix is at -6 and the center was at 0. And then y minus 0 squared. Now, we don't need all of those zeros in there. This is really just x equals 1/24 y squared. Let's try another one, because usually seeing a couple helps. The next one says the parabola with a vertex at -2, 0. So that would be left 2, up 0, and a focus at -10. And I'm going to go ahead and just put that point there. I'm not going to make all of the little tick marks. I'm just going to make a mark that that's -10, this is -2. But it says that that's the focus. So the curve goes around the focus like this. And before I go to write the equation, I'm going to go ahead and note that if I start at -2 and I go to -10, my distance is 8. So that is going to be P. -2 is going to be the H. 0 is going to be the K. And since this is going side to side, it is going to be another horizontal. So x minus the x value, which is -2, so that should really be x plus 2, equals 1/4 times p, which is actually going to be -8 because it's going to the left. And then y minus 0, because that's the y part of the center. And then let's clean it up a little bit. This will be x plus 2 still. 4 times 8 is 32, so that's going to be -32. Y squared. And then the very last one says the parabola with a vertex at 3, 4. And a directrix at y equals 1. So that's going to be a horizontal line like this. So the parabola has to go away from it, which means it's going up and down. So this is going to be a vertical one, which means it's going to be y minus the y value of the vertex, which is 4, equals 1/4 times the distance between the vertex and the directrix, which is 3, because this is at 4 and this is at 1. So 1, 2, 3. And it is positive since the parabola is opening up. Then the x part is 3, so it'll be x minus 3 squared. And then let's go ahead and just clean that up. Y minus 4 equals 1/4 times 3, which is 12. X minus 3 squared.